Hello, and it's day 17 of the Electronic Sound Build Your Own Synthesizer Advent Calendar. And yesterday we got it to make slightly quieter sounds. I wonder if today we're going to get something that'll make different kinds of sounds. So let's open up door 17. And in door 17 we've got, it's another potentiometer. Okay. I wonder where this is going. Well, let's have a look at day 17, in the booklet. So day 17, today you'll receive a second trimmer, and we're going to connect this circuit. So this is a completely different circuit, or quite a lot of change. And when connected, the circuit behaves like the Atari Punk Console, a legendary noisemaker from the 1980s, originally made up of two NE555 timers. So the 555 timers are fairly well known. First one was a square wave oscillator, whose frequency was between 340 kilohertz, 300 hertz and 40 kilohertz, which is in the audible range, a little bit above. And then this was used to control the second timer, which was a delay circuit. So less than 10 milliseconds to more than that, and the output signal was played by the output amplifier. A loudspeaker without a casing doesn't have a good sound. However, you can improve it by simply mounting the speaker in the box. So now it's time to also do the cutout sheet. But let's do the circuit first, and then we'll get into the cutout sheet. Okay. Right. What have we got? So we're keeping the two caps and this stuff down here. We're taking this away. And okay, hold on, that capacitor is going to be slightly different, so we're going to take this wire away too. There might be more wires in this as well, so we're going to have a look at the wiring. Maybe time to get the wire kit out again. There, and that will be a straight wire as well, so we'll top that out. The two buttons are still here and still wired the same way. However, and we get to this other side. So where do these go? This way. And that's not actually a wire, that was confusing me. That was just a piece of stripped cable. Oh, so that still goes to this pin. But you see, that column here, I'm going to use this as a pointer, so that column here is not connecting to this button because it's actually between any of the button contacts. And this one here, I think it's on a row away from there, so it doesn't interfere at all with where the button is. So we've got to go past where the button contacts stick out. Okay. We've got a shortish cable, which I guess can go between this contact and, well, let me see. Does it fit any of the others? It doesn't really, does it? Unless it'll fit between that pin and there, it won't. So okay, we're definitely going to need more here. Plus they've moved one of these function jumpers again. So time for the wire kit. We'll start with the fact that we've got two simple jumpers up here, so we will make about this length twice. And again, I'll strip it first like I did before because that seems to be working quite nicely. and I'll just use this one as a guide about there. Okay, also do, got a teeny bit of insulation on the end of that. Let's get rid of all this insulation. Got a wire between this and just 1 pin short of the 386 amp. Let's call it about there. I'm going to just store that right where it needs to go. Yeah, and the next one we need is that one we have. This one, which goes up to there. Well, that's a nice tangle. Let's untangle that first. So that's what, pin 3 across to that bottom leg there. If I say, well, there's pin 3, leave a couple of millimeters. There's that leg there, again a couple of millimeters. So we go from that pin 3. I mean, they're showing it right up against there, which I guess we can do. And then that just has this slight kink. I'm not going to be able to follow their slight kink, so let's just... getting a bit tiny in there, so let's use my pliers. I don't think it's tweezer work, but it's certainly pliers work to line that up. There we go, we've got one of them in, and let's do the next, which goes from pin 2 to the leg of that other pot. Okay, so there's pin 2 down here. And leave a couple of millimeters to the leg of the other potentiometer, a couple of millimeters there. Oh, I might have over-egged the insulation I took off there. Okay, well, it doesn't matter. I can still bend it closer than that insulation, so that's fine. So there's pin 2. And there's the leg of the other potentiometer. So, going to use the pliers just because sometimes they just don't want to go in. Okay, I guess next let's bend these into shape. Oh, we got another one going down here. Hold on, I'm not quite done yet. Not quite done yet. And the one going across up here, we said we would reuse. Oh, we did reuse, did we? Yeah, okay. Right, so between there and there. So it goes to this leg from this leg. This leg up here down to that leg over there. Again, you see these are getting quite tricky. Is it because I'm leaving these a bit too short? Maybe I have. Oops. Let's take out the bend in the middle because that won't be helping me. Sometimes I find also with breadboard is that holes you've never gone into are a bit stiffer than those you've used before. You see, that one is too short. So the one I've just cut is too short, so I'm going to use the one that I thought was a bit extra. There we go, okay. Wastage, oh well. It's slightly frustrating. Okay, so this actually goes down to ground through an elaborate, like slightly elaborate route, but it is just down to ground. So chop that there. I need to bend it like that. Nope. That's already got a slight kink in it, which makes it slightly awkward to bend. That may cause some trouble going into the breadboard. Yeah, it does, and that might have been where there was a bend point in the, or where the wire was wrapped around like that, you see. The way they've stored the wire, causing some slight issues. We can always test that a bit later to make sure that really went in. Okay, right, that will have to do. And so that's going from this leg here up to the voltage. That's the positive terminal. Rail even, I suppose you could call it either. And I have put that not connected to the right leg. Now, here comes the fun part. They have shown us, oh, and I need to move this pin, sorry, this one here out. They have shown us what colour codes we need for the resistors, but now I need to make sure I can see them on the resistors. And I think my lighting is good. So the 1K we're going to store on the board again. That must be not a 1K. Green, blue. Well look, that's this one. So that's the 550. So that's going from here down to ground. Looks like we're having a fixed volume because of this 15K here, which I think... See, we've got this one up here because again we got brown, green, black, orange, brown. Okay, which means none of those ones that were just stored on the side, but it does not matter. It really does not matter because these are on this up on this side are not connected. And will not be a reason that this circuit isn't right. Okay, let's check all of these connections. So the LED's in the same place. That goes across to this 15K. We've got the capacitor across to here. The two capacitors up here are in the same place, going up to the speaker, which might be a bit quiet because we haven't got the box around it. We've got this going to this pin. That pin goes to ground. That pin also goes to ground because it's connected across to that pin. That pin's positive. That pin goes and controls one function. That pin connects to the other, which might be the two analog inputs of this. We've got two buttons as well. I don't know what the two buttons do, so those are still connected, if anything. Right, we should be able to hear a sound, and then we can figure out how to deal with our cardboard box. So let's see if we hear anything. Ooh. Do these do anything? No, they don't do anything. Well, this is fun. That's like an octave thing. Almost. And then this has this. Ah, that's quite fun, isn't it? I quite like the noises I'm getting out of that. I guess next is to manufacture this little box they've got for us. Okay, these scissors will do for the rough cuts, but they're perhaps insanely large for the little tiny cuts. But let's get into this, and I'll hold it above so I don't accidentally cut through any of my wires. At least I know how to fix it if I do. And now I'll go and get some finer scissors for the finer work. And there we go. This kit has been opened, it has been cut, it has been bent, it has been in all ways defaced. I've even drawn in the manual. So it's a bit of a one-time use kit really, isn't it? But I guess that's the point, it's an advent calendar, so that's fine. Right. Do I have any finer scissors? I'm sure I do somewhere.
Can you be bothered to get the finer scissors? I'm sure you are not.
Well, these are great big fabric scissors. Let's see what I can find. As I think I've suggested before, half my lab is in storage, so aside from those giant scissors, I've now got these little tiny sewing scissors. Well, from fabric scissors to sewing scissors, I mean, there's a pattern emerging here. Some time later, now I've got to get in and do these little circle bits. My thinking is I would stab it, but these scissors aren't quite good for it. I think I need a craft knife. Okay, cutting mat and a craft knife. This is not the sharpest of craft knives, partially because I've previously used this to attempt to cut through 4mm sheet styrene. And to be honest, you're generally in that case better off working with 1mm or less and layering up or going with sections, because 4mm of styrene is quite a lot of material to cut through. Maybe I need to get a different craft knife, because this one, I mean, this one is blunter than blunter than a spoon, frankly. There we go. That's a sharper craft knife. And I am using a cutting mat so I don't destroy my desk here, and I presume you do the same, especially if you're using the dinner table. Be it your dinner table or anyone else's, you probably don't want to put cut marks in it. Well, I don't know about you, but these are going to come out more octagonal than round, so...
Octagons are better than circles anyway.
Guess if you're doing punk consoles, octagons are more punk, really, aren't they?
Circles are boring, fight me.
Am I going to need to go back round some of those other ones? Quite likely. This is not going to be the lovely tidy holes that they've got, because I'd much rather be going through it with a drill, frankly, but drills don't work particularly well on cardboard, so...
Drills
Actually, the drill is not in storage.
Oh.
Drill's one of those things I opted... Oh, look at the state of that. It's a bit jagged, but maybe what I can do is maybe I can tidy it up with the scissors a little. Huh. Famous last words, but that's not the tidiest of jobs. So just in case anyone was under the impression that I'm some kind of crafting maestro, master or expert, no, I just persist in it.
I'm sorry, Dad, but nothing you do is tidy. Properly clean.
Oh, well, you know what? I'm going to keep the slight jagged look. That's kind of cool, unique. There you go. We'll just trim off the tear outs.
Everything you do is cool, man.
Time to find some glue. So my PVA glue is in storage, so I'm going to go with something else. I'm not going to go as far as saying the next best thing, because it's clearly not, but this is double-sided tape. So if I stick a strip of that onto these gluing tabs and then chop it off here, and not too worried about finding the end, because actually it's reasonably easy with double-sided sticky tape. There we go. I've also not really thought about how I'm going to stick the actual speaker to the back of this, but we'll figure that out when we get there. We have punditry from Mini Orion Robots here as well. Top quality punditry.
To be fair, you've done better than I would have.
And what I should do before I peel these is let's go and score the fold lines, just so it's going to be easy to fold. And I should score these fold lines because those are going to be the trickiest ones. And we can do some video editing magic to do a before and after to see if this speaker box was worth the effort. I mean, it should resonate somewhat with the speaker. That is what you kind of expect, but I'm not holding an awful lot of hope of that. Right, there we go. So that's one side inexpertly joined in. Oh, so this is part of a box. And I don't know, but it may be that I need to do the other side. Oh, is that supposed to be the edge that that's supposed to be the edge for the speaker wires to come out with? That's a bit frustrating because I'd have to then build it around the speaker. Oh, well, I can poke them through afterwards. That's fine. Okay. And one more to glue. There we go. We have this box. So I'm not sure what the other box is for, unless the two are supposed to form two halves. It is about the right size. Okay, let's bring this over here, and I guess what we can do, put the wires through where they show them going through, or where they've left what appears to be a corner, which I presume is the wires to go through. There's no picture showing that at all, actually. Well, no, it does show actually it's stood up like this, doesn't it? It shows it stood up. So, okay. We've got those poking through there. Okay, and now we need the tape. It's almost the same height. I mean, unless you would push it together, but I don't think it'll hold the speaker in, so I'm not convinced that's what it's for. But if any viewers have tried that and had success, do let me know in the comments section. And viewers, if you've had difficulty, let me know. And if you've resolved your difficulty, let me know too. Let me know how you resolved it. I mean, it's probably useful for me and probably useful for other viewers who've got the same kit, or just in general wanting to know about such kits. Right, that's one side. Maybe I shouldn't have peeled it before sticking the other side. Ha! Okay. There's the other side. nearly there. You know, I really hope putting it in a box like this was worth it. It might just be some certain amount of resonance to amplify it, I suppose. There we go, stick the speaker onto the double-sided tape. It's not falling off. Okay, that's good. It sort of makes those, puts those wires in a awkward place, but so one side can go here because it goes to ground anyway, and the other side is the output of there, which I'm not going to put where it's going to get interfered with. That's still on the output of that second capacitor. Okay, moment of truth. Let's put the batteries in and see if it sounds any better. Okay, I mean, it might take some practice and mastery to be able to make tunes. I'm not quite sure it's tuneful so much as just intriguing, interesting. Subtle note here, because I didn't quite read the manual. It says about the cutout sheet, but it said the instructions will be found at the end of the booklet. And so, if you have a look at the end of the booklet, it certainly shows us cutting out both cardboard parts and using small pointy scissors, nail scissors, to make the rings. So I am going to go and cut out the other part, but I'm not going to make you endure it because it took a bit literally too long for the first one. Right, I have made the back for it after seeing what the sheet had to say. Very much the same process as the first, but without the big circles. And does it sound any different? That sound very much reminds me of some of those 8-bit computers. I had a Commodore 64 when I was a child, and it has a very similar sound to it. So yeah, I can see where this 1980s thing, I mean, they say it's based on the 1980s Atari Punk Console, and I can see why, because it's got that kind of 8-bit tune sound to it. Okay, I think we're going to make more terrible noises, but this time with the oscilloscope connected. So, the output of there I'm expecting just to be DC. Oh, wait a second, let's we're on channel 2, I want to adjust channel 1. And I think that's just changing a voltage. This one over here too. Ooh. But what are we getting on the output here? Let's see what's on this pin. Ah, there we go. If I just bring that down. That's me changing a frequency. You can see a square wave. Okay, what about this other side of the capacitor? So we can go on this pin here, the amp. Oh, and that's going to be a much lower voltage. So there we've still got our square wave. So it is still kind of a square wave, but it's almost a sawtooth. Okay, and at the speaker output itself. Oh, and we'll bring that down. And now we're all at sawtooth. So it's taking off the DC component of that square wave and just leaving these upticks. Now I suspect if I go the other side of that capacitor, this side here we can see the square wave. So we've got, I suppose, quite a wide duty cycle for the on and quite a slow one for the off. It's not doing great with the triggering. There we go, that's better. So quite a wide duty cycle for on, quite a small one for the off. And I'll put that over here again, and we can see that's just being turned into a spike. Oh, there we go, that's stable. I wonder if that... So that changes the bass frequency. And that changes. It's not quite octave, is it? It's almost harmonics. Well, I couldn't resist getting the oscilloscope out, so I hope you've enjoyed seeing it. We didn't do anything with the second channel. Oh well. But we can now see we've got a square wave one side, and through the op amp and this other capacitor we get a sawtooth. I think that's quite interesting. I hope you've enjoyed the video. I hope you've seen me struggling to put this thing together, although I think it's kind of got a cool aesthetic to it anyway. And, well, join me tomorrow, please. Go make stuff and be awesome. Bye.
Bye. Hey! Hey! Pardon me. Hope that wasn't on record. I'm like punditry, but you're just pungent.
Minnie and Ryan Robots loves recycling, even to the extent they like to recycle their jokes. Oh, I've done a great job of gumming up these scissors with a tiny strip of double-sided sticky tape. Nice.